So we have seen the problem for maximization using the graphical method. We will solve one more problem. Solve the following LPP by graphical method. So we have that objective function is given, that is minimize z is equal to 3x1 plus 5x2. Then subject to the constraints, 2x1 plus 3, this is 2x1 plus 3x2 should be greater than or equal to, is greater than or equal to 18. 10x1 plus 5x2 is greater than or equal to 60. x1 greater than or equal to 3, x2 greater than or equal to 2. So this is the problem. So once we take this problem along with the constraints, what we need to do is we have to convert the inequalities and equalities, and we should find the values of x1 and x2 for each constraint. Then we have to draw lines for them. Once we draw those lines, then we will be able to find out the feasible region. Once we find the feasible region, then what we will do is we will identify the corner points or solution points, and we'll also find the coordinates for those solution points, and for those solution points solution point coordinates or values we will apply in the objective function, and wherever we get in this context, in the context of this problem specifically, whichever the value we get minimum, that will be the solution point. Now we will solve this problem taking the constraints. Now we have 2x1 plus 3x2 is equal to 18. If x1 is equal to 0, x2 is equal to 6. Then if x2 is equal to 0, x1 is equal to 9. Then similarly for next constraint, 10x1 plus 5x2 is equal to 60. If x1 is equal to 0, x2 is equal to 12. Then if x2 is equal to 0, then x1 is equal to 6. Similarly, the other constraints, x1 is equal to 3 and x2 is equal to 2. So these values we will use for drawing the graphs, and we will find out the feasible region. So based on the graph, we have these points. We'll check this serial number, then solution point, whatever we have identified, and the objective function. Objective function value. So we'll substitute those coordinates. For first point is A. We have got points 3 and 6. where z is equal to 3 into 3 plus 5 into 6, which will give us 39. Now point 2 is B. The points what we have identified on graph is 4.5 and 3, where z value is equal to 3 into 4.5 plus 5 into 3, which gives us 28.5. Then third point we have identified, which we call that as C. The coordinates for this is 9 and 2, where z value is equal to 9 into 3 plus 5 into 2. Total gives us 37. Among these things, this gives us the lowest value. So the solution point is B, 4.5, 3, 4.5, since it gives us the least value in terms of objective function. So this is the solution.